Hola. Here we go, chapter 9. This is leaving the world of parabolas, entering back into what we would call the world of equations, and we're going to simplify and solve. So, here we go. First of all, the main topic is going to be quadratics. So, this is how you spell them. Meaning most of our things in this chapter will have a power of 2. All right? Though this first lesson we start off with actually the opposite of a quadratic, which is called a radical. You recall using this symbol before? Sometimes we call that a square root. We're going to call that a radical or a root. So, what is a radical or a root? Well, we have lots of radicals. This would be radical 9, also known as the square root of 9. And to solve that, we ask ourselves, what times what is 9? And the answer is 3. This is the square root. Okay, or the second radical. So we also have things like the third radical. And the third radical of 8 is 2. Because we ask ourselves, what times itself? 3 times is 8. And the answer to that is 2. Okay? So there are some examples of what radicals and roots are. You're going to be simplifying for your assignments. You won't be solving. That comes later on. And here are the 2 rules about simplifying. Rule number 1. We are not allowed any perfect square inside the radical. Or you're not allowed any perfect cube inside the cube root. Okay? You'll be mainly working with second roots and third roots, so there won't be anything higher than that. And then the last rule is that there are no square roots or cube roots left in the denominator. Now, what does that mean? Well, we know that fractions have denominators, so you can't have something down here, and you can't have a square root or a cube root around anything that has a fraction in it. Okay? So those are the main rules. Now, here are some reminders. Things to remember. You should have encountered this in the past already, but it's probably been some time. Maybe it was in 7th grade or 8th grade. 4 times radical 6 times radical 2. These radicals, since they're the same, they're both second radicals, square roots as we would know them, we can multiply those 2 things together and say this is 4 times 6 times 2 is 12. Okay? Sometimes you can even add radicals. In this case, because we have 4 radical 2 plus another radical 2, that's like a 1 radical 2. It's kind of like a variable, radical 2 is. So if I have 4 radical 2's plus 1 radical 2's, then I would have 5 radical 2's. Now if my radicals are different, we can't add those up. So this is like, nothing. You can't really simplify that. But we can divide. And so some of our problems are going to say, what do we get when we take 4 radical 6 divided by radical 2? Again, because these are both second radicals or square roots, I can divide those and I can say 4. Again, 4 is on the outside, doesn't mix, but if I take the radical 6 and put it over the 2 and ask myself what is 6 divided by 2, then we say that's radical 3. So the answer here is 4 radical 3. Make sense? So those are some rules to keep in mind as we go through and simplify some of these problems. One more term, fancy term, this won't come to the very last problem that we do in our notes, and that is, what is a conjugate? in essence, we're switching a plus for a minus or a minus for a plus. Okay? Meaning, if I have 5 minus radical x, change that to 5 plus radical x. Or if I have 3 plus radical 2, then I would change that to 3 minus radical 2. So those are conjugates, and that's going to be important. We can't add these things up. Notice none of them combine. So that's going to help us solve the last set of problems. Finally, what are some perfect square numbers? These are numbers which you need to use throughout the lesson. And so this is a good list of numbers to have at the top of your sheet whenever you're doing these problems. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. What is 4 times 4? 5 times 5. 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. And 12 times 12. These are the most popular squares, and if you know those and you recognize them, then your work's going to go a lot faster. Finally, some of the problems you're going to have are involving cube roots, so you need to know your perfect cubes, just like you know your perfect squares. So 1 times 1 times 1 times 1 is still 1. And again, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4, your calculator will tell you is 64. 5 times itself 3 times, or 5 to the third power, is 125. 6 to the third power is 216. And there are more. We don't really need to know any more. Those will suffice. In fact, if you know the first 4, you'll be fine with the cubes. Okay? It's important that you recognize these up here, though, these squares. All right. Simplifying radical expressions. Here goes our first problem. What is the square root of 18? Now, at first thought, you look at 18 and you go, well, that's not on the list. And you're right, it's not. So what we're trying to do is find anything in here which is hiding a perfect square. Now, that's rule number 1. You can't have a square root, perfect square in a square root. So what I want to do is take 18 and break it up into two numbers which multiply together to give me 18. Now, they won't be the same numbers. And the first 2 numbers that come to mind are 9 times 2. Well, that's really convenient because notice 9 is on my list. So 9 is a perfect square. So this number can be simplified by saying, what is the square root of 9? And then we're just going to leave the 2 inside there. So this problem becomes 3. That's what happens to the 9. And then the 2 is stuck. I'm going to do a similar type problem here, only this one is going to have a variable as well. I should circle my answer. We're done. So now I've got a 108 and an x cubed. I'm going to deal with those 2 things separately just because it's easier. Looking up at the 108, do any of those numbers up there in my list of perfect squares divide into 108? I always start with the smallest number and work my way up. And if you find one, pull it out. Now, know that obviously you won't have to go above 100. Okay. We never need to check 1 because 1 doesn't help us at all. Does 4 divide into 108? And it does. Now, I could take 4, and again, I'm going to say 4 times, I believe it's 27. But there's a better answer, meaning 4 is a perfect square, but there's a higher square in my list that also divides into 108. And I'll let you take a minute, a few seconds here to figure out which of those numbers. Does 9, does 16, does 25, does 36, does 49, does 64, does 81? One of those numbers divides into it. Well, hopefully you found it. 36 does. In fact, it goes into it 3 times. So the first part of my problem here, I'm going to say is, I shouldn't forget about my x cubed. We'll just leave that on the very end here, okay? Is 6, because notice the 36 comes out as 6. The radical 3 is stuck. Now, what to do with the x cubed? Well, it looks like the 3 isn't a perfect square. But remember from our days of the polynomials and multiplying things together, you and I know that x squared times x to the first is a way of getting x cubed. And if I take a square root of each one of these, notice the x squared comes out as just x. This guy gets left inside. Okay, so I'm going to have an x come out, and then I've got a square root of x stuck inside my radical. All right, so again, the x cubed, I broke it up as x squared times x. I took a square root of each one separately, and that's how I got my x times x. My final answer, let me just clean this up a little bit here, is the 6 came out, so I'm going to write it first. The x came out, so I'm going to write it next. And then the things that are left inside, I'm just going to write together. So 3x. Notice this is all multiplication. Okay? So we can rearrange order however is convenient to us with multiplication. If there's addition in there, it's a big mess. But with multiplication, you can switch things around. So there's my answer, 6x times radical 3x. All right, before I go into the next problems, these are your homework problems that you're working on in this case. So the first set of problems I think you're going to be doing is the even problems, or the odd problems. I'm going to do the even ones for you, right? So if it is in simplest form, you say. If it's not, then you explain why it's not. So this rule, this violates, you can't have a fraction. No fractions inside of square roots. Is there a perfect square hiding in 34? No, it's just 2 times 17, and that's the only way you can break up 34. So 2 and 17 aren't. So this is simplest. Can't do anything with that. This one, 10. Well, 10 is only 2 times 5, so that's not going anywhere. The 3 and the 4 don't simplify. So that problem is cooked, as we say. It too is simplest form. Now the 54, is there something hiding in the 54 like a cube? Notice this is a cube root. And so I check, do any of these numbers divide into 54? And sure enough, 27 does. So for this problem here, there is a cube that's hiding in there. So I would be able to simplify it. Again, this problem doesn't say to simplify it. It just says determine whether you can or not. All right? So in these problems here now, in 13 to 20, you will then be simplifying these. So that's where you do things like, okay, take 20. Are there any perfect squares? Again, 16 times 2 is what you would do there. Oh, so that's 4 times radical 2. Okay? All right. I'll let you work on that. I'm going to keep going with the video and do the next 2, and then I'll pause and I'll make another video for the rest of it, because this is a long exercise that we're working on here. All right, square root of 15 and square root of 54. I think the first thing we should do maybe is break this problem up into 2 little subparts. Yeah, kind of like we did in the previous problem. Here, I'm going to break this up into two parts. Now the square root of 15 I think is done. 5 times 3 is the only way we can factor 15. Nothing else divides into it, so there's no perfect square. But 64, there is. In fact, if I look up on my list, right, it's on both lists, but be careful, we're looking at perfect squares. So what times what is 64? And the answer is 8. So there's my answer, square root of 15 over 8. Notice one of those things is outside the square root, the other one is inside. Don't mix them up, okay? That's done, that's cooked. Now here, 81 and x to the 4th. Again, think about this as two separate problems. Radical 81, radical x to the 4th. What times what is 81? 9. X to the 4th. Oh, well that's x squared times x squared, isn't it? So my answer is x squared. So there's my answer, 9 over x squared. All right, so some of your problems are going to involve square roots and, fractions inside and simplifying them. All right, so again, 65, 121, break it up, two separate problems. Work on them separately. If there's a negative outside, leave it outside. We'll talk more about negatives, okay? I think this is 65, square root of 65 over 11. Okay? All right. And I'll have a second video now for the second page of examples, which, sorry, this lesson gets kind of long. Radical expressions, part 1 done.